A strange traveler has entered our solar system, one that came silently from the depths of interstellar space, carrying secrets hidden within its icy layers. From forming its tail in the opposite direction to displaying behaviors no normal comet has ever shown, scientists are seriously asking, is this really a comet or a time capsule sent from another cosmic world? And what exactly is going to happen in December 2025, when something rare and extraordinary is expected from this object, something the entire scientific community is impatiently waiting for? July 2025. It all began on a cold July night in 2025. 3 major observatories in Hawaii, Chile, and South Africa were scanning the sky as part of an advanced detection system called ATLAS, Asteroid Terrestrial Impact Last Alert System. Its mission? Scan the sky and warn Earth about dangerous incoming asteroids. But that night, ATLAS noticed a faint moving dot that looked harmless, just another small asteroid, until scientists calculated its speed. And everything changed. The speed that shocked NASA. Every object in our solar system obeys the sun's gravity and orbits at predictable speeds. For example, Mars, about 24 kilometers per second. Earth, around 29.8 kilometers per second. Venus, around 35 kilometers per second. Mercury, around 47.9 kilometers per second, the fastest planet. But this new object, it was moving at over 58 kilometers per second. That's too fast for any object bound to our sun, especially since it was detected near Jupiter, where objects normally travel much slower. The conclusion was undeniable. This object did not belong to our solar system. It came from another star system. NASA officially declared it the third interstellar object ever discovered and named it 3I Atlas. 3I meaning third interstellar object and Atlas after the telescope system that discovered it. It had been seen before, but missed. After confirmation, scientists searched older data and were stunned. The same object had been recorded 2 months earlier in May 2025 by another survey telescope, TEST, but it wasn't recognized at the time. Only after its speed was calculated did the truth become clear. How 3I Atlas differs from earlier interstellar visitors. Before it, only 2 interstellar visitors had ever entered our solar system. Oumuamua, 2017, Comet Borisov, 2019. But 3I Atlas is not like them. 1. Size. Oumuamua, about 400 meters long. Borisov, about 1 kilometer wide. 3I Atlas, about 5.6 kilometers across. Massive in comparison. 2. Speed. It is traveling nearly twice as fast as the earlier interstellar visitors. 3. Entry angle. Most solar system objects lie in a flat, disc-like plane. Oumuamua and Borisov entered from above this disc. But 3I Atlas entered from the side at a razor-sharp angle, like an arrow hitting a perfect target. Scientists call this a cosmic coincidence of unimaginable rarity. Where did 3I Atlas come from? Tracing its path backwards is like traveling through time. When scientists simulated its trajectory, they discovered it likely originated from an unknown star system in the thick disk of the Milky Way, a region that contains ancient stars. Its estimated age? 7.6 billion years, nearly twice the age of Earth. And during its million-year journey through space, it never passed as close to any star as it did to our sun. This is a traveler unlike anything we've ever studied. The first strange behavior. Far beyond Jupiter, around 5 AU from the Sun, Atlas did something bizarre. Comets normally stay frozen until they get much closer to the Sun, but Atlas began forming a coma, a cloud of gas and dust, extremely early. This unusual early activity revealed that Atlas is rich in carbon dioxide ice, a type of dry ice that vaporizes quickly. Then came another surprise. Its coma contained nickel, but no iron. Every comet we've ever studied contains both because they form in dying stars where nickel and iron coexist. Atlas was breaking every rule. But things got stranger. The most extreme negative polarization ever seen. As sunlight hit its coma, scientists measured how the light scattered. Normally, light scatters upward or downward, positive polarization. Even earlier interstellar objects showed this. But Atlas did the opposite. It reflected light back toward the sun, negative polarization. And not just negative, the most extreme negative polarization ever recorded in any object. This suggests a surface structure unlike any known material. Then it formed its tail backwards. When comets enter the solar system, their tails always point away from the sun due to the solar wind. But when Atlas entered, its tail pointed toward the sun, as if a person stood in strong wind and their hair blew forward instead of backward. Scientists were stunned. No known comet behaves like this. Later, closer to the sun, its tail corrected to the normal direction, but the mystery remains. Closest encounter with Mars, October 3, 2025. As it passed Mars, NASA's rovers and orbiters managed to capture rare images of the interstellar visitor drifting across the Martian sky. Though the cameras weren't designed for this, the pictures became historic. Perihelion, October 29, 2025. This was the moment scientists eagerly awaited. Atlas passed its closest point to the sun. Unfortunately, from Earth's perspective, it was behind the sun, hidden by solar glare, so we missed observing its peak activity. But before disappearing behind the sun, it gave scientists plenty of mysteries to investigate. What's coming next? December 2025 and March 2026. Two major events are still ahead, and scientists are excited. 1. December 2025, Earth's best view. Atlas will emerge from behind the sun and pass relatively close to Earth. This is the moment to check, did the sun's heat change its shape? Did its surface crack? Did its chemicals react in unusual ways again? Everyone is waiting. 2. March 16, 2026. This will be the last time Atlas gets close enough for detailed study. NASA's Juno probe will attempt to capture high-resolution images as it passes Jupiter. After this, Atlas will leave our solar system forever, never to return.